Good morning everyone. Dear students, in our last lecture we learned about the experimental study of photoelectric effect, in which we first draw the circuit diagram for study of photoelectric effect. Then we explain the construction and working of photoelectric effect, that is experimental diagram. We allow the light of suitable frequency to incident on the emitter through the window, quartz window in the evacuated glass tube, and then with the help of different graph we explain the variation of photoelectric current with frequency, with intensity, with accelerating PD between emitter and collector. Then we also discuss the variation of photoelectric current for different intensity, how saturation current is different but same stopping potential. Also for different intensity and for different frequency, how the saturation current is same but the stopping potential varies. After the complete explanation of that experiment on photoelectric effect, now we have to make some observations, and that observations we have to study here. So the observations from experiment on photoelectric effect. So these observations are very important. We can say that these are the characteristics of photoelectric effect which was explained experimentally. So the observations from experiment on photoelectric effect, that we have to discuss now. So see here, first observation is the photoelectric effect takes place only when the frequency of incident radiation is equal to or greater than the threshold frequency. This is first observations which we make during the experimental study of photoelectric effect. What it says, the photoelectric effect takes place only when the frequency of incident radiation is equal to or greater than the threshold frequency. In short, we can say that photoelectric effect is possible only if the frequency of incident radiation is equal to or greater than the threshold frequency. That frequency in Marathi we call it as umberta frequency. Actually not the same word, just to remember. अशी फ्रिक्वेन्सी की ज्या फ्रिक्वेन्सीला फोटोइलेक्ट्रिक इमिशन सुरू होतं त्याच्या अगोदर जे इन्सिडेंट लाईटची फ्रिक्वेन्सी असेल तर त्या फ्रिक्वेन्सीला फोटो इलेक्ट्रॉन्स इमिट होत नसतात. ज्या फ्रिक्वेन्सीला फोटो इलेक्ट्रॉन्स इमिट होतात त्या फ्रिक्वेन्सीला म्हणायचं थ्रेशोल्ड फ्रिक्वेन्सी. थ्रेशोल्ड फ्रिक्वेन्सीच्या वर जर फ्रिक्वेन्सी वाढत नेली तर फोटो इलेक्ट्रिक करंट वाढतं. हे जर आपल्याला एक्सप्लेन करायचं ग्राफिकली, आपण हे एक्सप्लेन केलं होतं खरं तर. फोटो इलेक्ट्रिक इफेक्टमध्ये हे ग्राफ आहे, समजा वाय ॲक्सिस इकडे घेतला आपण एक्स ॲक्सिस. एक्स ॲक्सिस वर असतील फ्रिक्वेन्सी आणि वाय ॲक्सिस वर होतं फोटोइलेक्ट्रिक करंट. इथं काय किंमत असेल दोन्ही फ्रिक्वेन्सीची आणि करंटची? इट इज 0. So on x-axis we take here frequency of incident radiation, on y-axis there is photoelectric current. Initially both the values are 0 If we go on increasing the frequency of incident light like this, initially there is no photoelectric emission, but as soon as this value reaches to a particular value, then photoelectric current starts and it goes on increasing with increase in frequency. So this frequency is called as threshold frequency. So this is threshold frequency. So see here, it is clear observations. Initially with increase in frequency there is no photoelectric current, there is no increase in value of y-axis as we go on increasing the value of x-axis, but as we reach to the value called as nu zero, electrons are emitted, means photoelectric current starts, and beyond this value if we go on increasing the frequency, photoelectric current also increases. So this was the first conclusion which leads us to define a new term called as threshold frequency, that we have to define later on. So this is the first part, we can say how photoelectric effect takes place for the frequency equal to or greater than threshold frequency. Now next, so first conclusion or observation, photoelectric effect takes place only when frequency of incident radiation is equal to or greater than threshold frequency. Now let us move to second conclusion or second, that is observation. Photoelectric current is directly proportional to intensity of incident light. Second part of experiment was varying intensity. First part was varying frequency. Depending upon that we made first conclusion. Now second part was varying intensity, keeping frequency and PD constant. If we go on increasing the intensity while frequency which is greater than threshold frequency is kept constant, rheostat position is kept constant. If we go on increasing the intensity, what is intensity? It is energy radiant energy incident per unit time per unit area. It is also, we can say that the number of photons incident on the plate per unit time per unit area. So this it is observed that photoelectric current is directly proportional to intensity of incident radiation. Means as we go on increasing the intensity of incident light, this photoelectric current is observed to be directly proportional to intensity of incident radiation. This is intensity of incident radiation. If we go on increasing the number of photons incident per unit time, the photoelectric current increases. So this is the second observation from the experimental study. Now see your third observation. Photoelectric effect is instantaneous phenomenon. It is also very important observations from photoelectric effect, the study of photoelectric effect we can say. The photoelectric effect is instantaneous phenomenon, that is there is no time lag between incidence of radiation and emission of electron. What does it means? As electrons incident on this plate, emitter plate, as electrons incident on this plate, the photoelectrons are emitted. Suppose this is electron, photon, this photon incident on the metal plate. At the same time, the electrons which are present in this metal plate are emitted out of the plate. There is no time lag between incidence of photon and emission of electron. As soon as photon of energy h nu incident on this plate, the electrons absorbs energy through this plate in this plate through the photon and it come out. This phenomenon is instantaneous. There is no time lag between incidence of radiation and emission of electrons. याचा अर्थ साधा सोपा काय, आज आता ताबडतोब म्हणजे जसे फोटॉन पडले तसे इलेक्ट्रॉन बाहेर पडणं. असं नाही की फोटॉन पडले, इलेक्ट्रॉननी वेळ घेतला, ॲब्झॉर्ब केलं, त्यांचं स्वागत वगैरे केलं आणि नंतर मग इलेक्ट्रॉन बोलले की नाही चला आपण बाहेर पडू, असं नाही. जसे फोटॉन पडले त्याची एनर्जी ॲब्झॉर्ब करतात इलेक्ट्रॉन आणि लगेच बाहेर पडतात. म्हणजे मुन्नाभाईचा फॉर्म्युला यूज करायचा. गांधीजीचं जसं होतं की एका कानाखाली काढली तर दुसरा कान पुढं करायचं, मुन्नाभाईने फॉर्म्युला बदलला. काय केलं, एका कानाखाली काढली, यानं विचार नाही केला, लगेच दुसऱ्या कानाखाली काढली, दुसऱ्या गालावर मारल्यानंतर. त्याला म्हणायचं ताबडतोब प्रतिक्रिया. तसं फोटो इलेक्ट्रिक इफेक्ट हा इन्स्टंटेनियस असतो. देर इज नो टाईम लॅग बिटवीन इन्सिडन्स ऑफ फोटॉन अँड इमिशन ऑफ इलेक्ट्रॉन्स. म्हणजे जसे फोटॉन पडले लगेच इलेक्ट्रॉन बाहेर पडतात ताबडतोब, तिथं वेळ नाही जात. जसं इस्रायलचं तर सैन्य करतं, त्यांचा एक सैनिक जर मारला की ते लगेच ताबडतोब जाऊन तिकडे 2 सैनिक मारून येतात. असं नाही की किती मारले, कसे मारले, कोणी मारले, त्याच्यावर आयोग वगैरे, बिलकुल नाही, ताबडतोब चटकन. त्याला म्हणायचं इन्स्टंटेनियस. तसं इथं इन्स्टंटेनियस फोटो इलेक्ट्रिक इफेक्ट इज इन्स्टंटेनियस फिनॉमिनॉन. दॅट इज देर इज नो टाईम लॅग बिटवीन इन्सिडन्स ऑफ radiation and emission of electron. So this is the third observation made from the experimental study of photoelectric effect. So this is third observation. Now see here fourth observation. How we can make fourth observation? See here carefully. For a fixed frequency and intensity of incident radiation, the photoelectric current increases with increase in accelerating potential. It becomes maximum and remains constant. It is called as saturation current. What happens here? If frequency of incident radiation is kept constant, see here how we can draw the graph. See here, on x-axis we take here the potential accelerating PD. It is accelerating PD. On y-axis we plot here the values of photoelectric current. So this is photoelectric current. We can consider here the negative part also that we have to draw in next part. So here it is negative potential, then first it is positive. What about this point? It has both the values 0 initially. What is potential also accelerating PD and photoelectric current. See here carefully now. For a fixed frequency and intensity, means frequency of incident light greater than threshold frequency is kept constant, and intensity, that is number of photons incident per unit time per unit area, is kept constant. What we have to change? Photoelectric current increases with increase in accelerating potential. Even the potential is 0, there is some photoelectric current, and beyond this value, if we go on increasing the potential, the current also increases like this. It becomes maximum and it remains constant. See here, this graph is parallel to voltage axis, potential axis, means if we go on increasing potential, then also there is no change in value on y-axis, means photoelectric current remains constant, and this photoelectric current becomes maximum and remains constant. It is called as saturation current. This value is called as saturation current. So if we go on increasing, first which quantities are kept constant? Intensity and frequency are kept constant, and potential is increased gradually. Even potential is 0. Electrons are so energetic that they can move towards the collector, and collector has to accept them, due to which current flows through the circuit. Now if we go on increasing the accelerating PD, the current also increases rapidly. It becomes maximum and then it remains constant. Even if we increase the potential or accelerating PD, there is no any change in potential or collector current. So this maximum value of collector current is called as saturation current, which is maximum one. So this is fourth observation from the photoelectric effect, the study of photoelectric effect. Now see here, the fifth observation we have to make here. What is fifth observation? See here carefully. For a negative collector potential, collector current reduced to 0, that potential is called as cutoff or stopping potential. So, for a negative collector potential, see here the same graph. First, here is positive potential. If we go on increasing the positive potential, current increases, it becomes maximum. That maximum value is called as stopping potential. Now, if we go on decreasing the collector potential, what happens? The collector current also reduces. It becomes this much at 0 collector potential. Now, the polarities of battery are reversed as per the working. We have seen in the working how polarity of battery change using the commutator, and we can now increase the negative potential given to collector using the rheostat. Now, if we go on increasing the negative value of collector potential, what happens to this current? This current now reduces, it decreases. See here how it decreases. This decreases and it reduces to 0. So, this is the point where the collector current reduced to 0. This value is called as, it is stopping potential. It is denoted by either V0 or Vs. So, how it happens? See here, if we go on decreasing the PD, photoelectric current decreases, it becomes this much value of current, even the collector potential is 0. Now, if collector is given negative potential, and if you go on increasing the negative potential given to the collector, what happens? This collector current decreases slowly and it becomes 0 at what value? This is the negative value of collector potential, and that negative value is called as stopping potential. This value is called as stopping potential. So, this is very important part, the concept of stopping potential here. So, these are the observations made from the experimental study of photoelectric effect. So, the experimental study of photoelectric effect leads us to make about 5 concluding points or 5 observations. So, these are the 5 observations made from the photoelectric effect, experimental study of photoelectric effect.